thanks for joining us today. This is our third or something like that user update, or monthly user update. And today, actually, it's a little bit different from the last updates, and we're going to keep changing the agenda and the topics and the focus around over time as we go from hibernating to ramp up to regular operation. Today, we're actually going to cover a fairly broad range of topics that are covering a lot of different smaller areas. So it's a lot of different little slides, and hopefully there's something of interest for most of you, as you can see in this kind of overview here. So to start, I wanted to quickly look at what actually happened in the last couple of weeks in terms of fab usage and the number of people in the lab and the tools that they've used, and compare that maybe against last summer, so we have some reference point. So what I'm showing you in this plot here is it's a little bit of a strange graph. If I take if I count the tool uses per user, so I'm looking at this here, and I rank people by how many tools they've used, I can plot it on this log chart, right? And you can see that for a small number of people, you have a heavy usage, and for a larger number of people, you have very light usage, right? But it gives you kind of an overview of how the lab was utilized. And what you can see in this data set is actually interesting. It's fundamentally similar to what we saw last year, but a little bit offset, right? And what that allows us to do is to say, well, if I create a quote model, it's not really much of a model, but anyways, if I model that in quotes, I can find that if I were to take the number of users and the usage per person, that we're currently roughly got 50% of the people in the labs that we would normally have. And everybody who's in the lab, roughly, on average anyways, uses 60% of the tools that they would normally do, right? And so those are consequences of the reduced capacity of MIT, and it's also a consequence, most likely, of the reduced hours that we've been currently operating at. Now, important here to note, this is not related to the 25% ramp-up density that MIT has, because the lab, in the end, the fab has a fairly large capacity, right? We could accommodate a couple of hundred people in principle based on the square footage. So it's really not related to that 25%. It's a little bit tempting to make that comparison, but it's not valid. This is what happened over the last 5 weeks. And it's perhaps also interesting to look at what happened over time. And so, again, in reference to 2019, these were the daily number of users, so how many people were in the lab. And this is measured by number of different choral engages, right? So whoever engaged the tool on a particular day counts as a user that day. Obviously, there's some people that may go into the lab and just pick up samples, so we don't count them in this. But what you see here is relative to 2019, we see in the early parts kind of the ramp up here, slow rise, and then subsequent increase. You also see in the fourth week a dip that was from the Fab 39 humidity related shutdown, and we'll talk about that in a little bit. If I were to just go for the first 15 days, which covers June, because we can pull the data out of months that we have, it actually is interesting to see that this is what we had in the lab, were 31 PIs and 55 different users. Right, so actually we were able to cover a fairly broad range of labs rather than just a small subset of intense users. Now, something else to potentially to look at here. So I'm going to try to quickly, any problems here, Kurt? No, all good. All right. If there are any issues with connection or something, just give me a chat. Well, there's a whole bunch of chats. Let's see. Hold on, my audio sounds crummy. Okay. How's that work? I'm going to stop my video. It's not much in the recording. All that happens is that it just shows anyways, which isn't particularly.
I mean, if everybody will turn off the video besides Jorg, we will increase the bandwidth and be able to maybe hear better.
All right, let's give that a shot. How are we doing? No complaints, some complaints, let's see. Poor audio, okay. Well, that's like slightly better. Okay, hold on. I'm going to move around a little bit. It shouldn't matter, but who knows? Maybe we should have these meetings at like midnight or something when nobody else is busy. But anyway, relocate a little bit. How's this now? Good? Better?
That's good.
Okay. All right, good. I relocated. That's fine. All right, so let's resume then. What I want to show on the right here is actually the ratio of 2019 to 2020, right? So that gives us kind of how well or how busy were we relative to last year. And what you're seeing is two different things. You're seeing the ramp up in the first point here, and in the second point, that's the Fab 39 when we had the humidity or the lab shutdown, right? Obviously, that reduced the number of users. In building 12, what we see is sort of a more gradual rise because, and this is actually counted slightly differently. This is the number of entries, so it could be one really busy person going in 20 times a day, or we could have 20 people going in once, right? But again, sort of the trends are there that we're beginning to see people come back to the lab, which is great. And that brings us to next week. So July 22nd is when we actually will resume regular lab hours. And I'll explain that a little bit in the next slide as well. So the goal is to transition to normal staff schedules and resume the evening hours and get everybody to maximize the amount of chance they have to do work in the lab. And what we have is currently the ramp-up hours, right? This was from the last couple of weeks. It was a fairly restricted set of hours, right? 9 to 5. And what we're moving towards starting Monday then is the regular or the open hours of 8 a.m. to 9 p.m. with the evening shift and 7 o'clock on Friday, right? And hopefully that allows people to, or allows you to come in at a more convenient time and get more things done, because 8 hours is a fairly restrictive set of time because, you can't start a 4-hour run in the afternoon because you're going to run over 5 o'clock. Now, one other thing we're going to try to do, which could be interesting, is we want to, in the cleaning of the lab, especially in building 12, we may restrict access to the lab during that 1 hour in the early morning, just to get the cleaning staff undisturbed, working through that without having to people passing in and out all the time. So I guess technically that gets us to sort of an average 23.14 hour user. So you'll officially 24 hours, technically maybe not quite. On the other hand, we also want to really encourage you to help us maintain these expanded hours and be considerate of other users and the staff, practice social distancing. Most important, as we start ramping up now with the number of people in the building, please don't go into the staff offices to ask questions, utilize email, Zoom, etc. to discuss, because we want to make sure that people are comfortable working rather than being sort of chased around and in a non-socially distant way, I guess. And of course, whenever possible, work from home, both for users and staff, right? So if you're working on something, in the morning and you could do the rest at home, you may find yourself exiting at that point. Something really important here to emphasize, though, is that there's a difference between the PI labs and the MIT research ramp-up and the core facility ramp-up that we have. And I want to highlight that in the following way. MIT research ramp-up is essentially a timeline that's different than the core facility ramp-up. Today we're here where the arrow shows, and research ramp-up 1 started June 15. Ramp-up 2, there's been some emails coming out. There wasn't really any concrete date, so we don't really know yet, right? Maybe it's in 2 weeks, could be 2 weeks plus or minus a week, who knows? The core facility, or during the MIT research ramp-up, you go from shutdown, where almost just a very few people are on campus, to 25% to 50%. Core facility, we were hibernating in May. In June, we started going back up again, so that when our R1 came around, we had the reduced staff hours from 9 to 5. We then added 24-hour users back in July, and coming Monday, we extend the staff and lab hours to the 8 a.m. to 9 p.m. Notice that this is still during the research ramp-up 1, right? So while the lab may be open for longer amounts of time, you're still going to be constrained by that 25% that MIT puts on you and your PI's lab, right? So that doesn't going away. That's an independent problem. But what it really means is that by the time RR2 comes around and you're able to go to 50% density in your lab, in your PI's group, we're essentially already able to accommodate extended hours at that point. And that's really what we want to be, right? We don't want to react to RR2 coming around. We want to be able to say, okay, once we get an increased number of people, we know that we can handle that and deal with it. So these two timelines are decoupled to some extent, and it's important not to confuse them, right? It doesn't mean on Monday RR2 starts. It means on Monday we're trying to get ready for RR2, and hopefully you'll reap some benefits of that in the next couple of weeks already, even though we are still at 25%. That also brings us sort of to one potential problem, that's the gowning capacity, right? That's something we keep a close eye on. Right now, there's plenty of room, or enough room anyways. We were a little bit concerned about that. The data showed that it probably wouldn't be an issue. It hasn't been an issue so far. But we can imagine that later on, a whole bunch of people come in and we get a little bit more busy, perhaps too busy to accommodate with the current setup. In that case, what we can do is add capacity when needed, right? And so possible future solutions as they are needed could involve, and these are just some thoughts, right? Adding hangars and bags in building 12, maybe doing a midweek clean out in TRL and Fab 39, maybe doubling the lockers and using plastic bags. So there's a lot of potential solutions to address this issue. And so we're not super worried about that. We know we can accommodate it when the need arises. We don't want to jump the gun and just do it and cause extra inconvenience, right? That's, of course, true. Really just a few gowning notes. This is emails that come out, and I want to appreciate you paying attention to those, and we're trying to optimize. It's kind of tricky because everybody's trying to learn a different system at this point. Hoods or something like that, you probably don't want to have it on the outside of your garments because it's just other people touching, sneezing on it, whatever it is. So tuck that in as shown here. Same thing for the hangers, right? Label your hanger in Fab 12. In building 39, we're going to similar to the boots in building 12 here. We're going to shared boots as well because there's been a lot of chaos and boot hoarding, confusion, shortages that happened because people put the boots into the locker, which is what we in ICL used to do and TRL never did. And so I think that just created a little bit of chaos. So we put up some bins here, and hopefully that model makes it more consistent between 12 and 39, and hopefully that avoids shortages, right? If you have questions, let us know about this, and we'll help clarify or help improve the flow if that becomes an issue. So now I want to talk a little bit about the Fab 39 humidity and that recent shutdown in July that we had. And to give you a background, it's not just the processes that are impacted by humidity, it's also the equipment. Right? And so these are some pictures. This is an RIE turbo. Turbos are chilled water cooled, and so they become cold. If it's humid inside, you start condensing. So this almost looks like someone just sprayed the thing with water, right? That's not a very good situation to be in. There's water in or on RF generators. There was water condensing from pipes, like the green lines here, piling up on controller boards. So all these issues are things that prevent us from starting or running a tool because of the electrical hazards associated with essentially having the thing half submerged in water here. And that means we shut tools down, and that essentially is what happened in 39 in the last 2 weeks pretty severely. Right now, that was triggered. What's interesting about that, sort of what went wrong, right? And here's a brief timeline, and we're not going to read through this in careful detail, but it just shows that an analysis was done and between facilities and MIT or Nano. There was a compressor installation on July 1st. We were informed that they were going to do that on July 7 and 8. After a little bit of back and forth, it was agreed that that was acceptable despite sort of reservations because it's supposed to, that new system, supposed to help with the summer humidity problems. At the same time, then things didn't go as planned with that installation. And so the humidity rose to 60, 65%. What made it even worse was that cooling water that came into the building also dropped by 10 degrees. So that was like a double negative, double problem, I guess. Some of that then facilities was able to address, and they added some additional engineering support for that to check these problems. And fortunately now, 2 weeks later, the humidity seems to be coming down. Now this could be the repairs, it could be the weather. We'll have to figure that out. But that's essentially the brief overview of the error analysis, and other people have a lot more knowledge into depth into this, right? So what does it mean for 39 going forward? Humidity and cooling water are now returning to normal. We'll let the equipment dry, turn it on, figure out what's broken, restart those tools where it's possible, and then repair the damaged tools. All of that obviously adds additional work, additional detours, and additional delays, right? We're at this point roughly here. We're going to wait for things to dry. Some equipment is already on. Others may take a few days, depends on the tool and the severity and so on and the assessment. And then hopefully next week we can start, tools that are good, they're on, the others need to be repaired. And that kind of is an interesting situation to look at. And maybe what I want to do here is to look a little bit at the challenges for tool repair in general in this new normal situation that we are in now. And the way I want to do this is to look at, as a function of time, the repair probability density function. What is the odds of getting something repaired within a certain amount of time? And normally this is what it looks like, right? Everybody always tells you it takes 2 weeks to repair the tool. And that's maybe because on average it takes 2 weeks. But you see it has a fairly long tail here. It has, sometimes it gets faster, sometimes it's slower. Right? Now, in the current situation, though, this curve has shifted. And the way it has shifted, what we're finding now, is the following. Right? Two things actually have happened if we look into this. There's a general slowdown. You see that the peak has now moved. Maybe it's now 4 weeks. I'm making these numbers up, and it's based on experience. These are not measurements, obviously. But there's a delay in that peak. But worse than that is also that the tail risk has now increased as well. Right? So what used to be fairly unlikely that it could take 8 weeks has now, in my mind, anyways, has gone up. Right? These are changes that are not really due to technical problems, right? The turbo is still the same as it used to be. The tools haven't changed. What has changed are the administrative issues and COVID-related delays and slowdowns around repairs. So really these issues are not for technical reasons, which is at least the silver lining then is eventually they should disappear as things return a little bit more to normal. But in the meantime, we're stuck with this kind of new normal for repair of the tools. And it makes it very, very frustrating because it becomes extremely hard to predict. And I want to highlight that with one example, and that's the e-beam FP that has frustrated a lot of our users. Right? So in a normal situation, what happened here, there was a part that was broken. A normal path would be you install the new component as shown here, get the new part, install it, field service comes and visits, and you're done. Right? In this case, the field service has to patch some communication modules and so on, but maybe that takes 2 to 3 weeks, the whole process. There's 2 people involved and 3 emails are exchanged and problem gets solved. Now, what happens these days is a little bit different, right? So in this case, this is actually what really happened rather than what we're thinking might happen. What really happened is, well, we put the part in that was right before the shutdown, and then field service wasn't able to travel because of the COVID shutdown. However, then more recently, after we came out of shutdown, we were able to schedule field service. However, a small snag occurred. California started shutting down again, going into quarantine, and prohibited the vendor from traveling to Massachusetts. Once that was resolved now, there were some legal-like questions arose between MIT and the vendor because everybody wants the other party to certify that they are adhering to COVID standards. So that becomes a bit of a additional delay there. Then, right now we're sort of stuck with trying to figure out the Massachusetts 14-day quarantine exemptions for the vendor and convincing them that they're able to come. Then we'll have to figure out schedule availability and we'll probably discover, who knows, some other issues along the way, right? And so that shows you pretty much all of these issues are non-technical, right? And what that means is at the end of the day, when we're done, it probably involved 10 people and 40 emails rather than 2 people and 3 emails. And that dramatically increases your delays. And it makes it extraordinarily hard to predict because you don't know how long management of a company or MIT decides to review contracts and COVID promises and so on. So all these non-technical problems really add uncertainty and delays. And they're, for us, at least as a technical staff, really, really hard to predict, right? Because we're not lawyers, we're not contract negotiators, and so on. Sometimes we get not necessarily lucky, but a little bit better off. An example of that is the chlorine Samco. What happened there, the heating cooling problem started in January. We were troubleshooting with Samco and identified the electrostatic chuck right before the shutdown. That order, $45,000 part, was placed in March. Normal lead time is about 4 months. So because the order was, in some sense, we got lucky that it broke before the shutdown because we were able to get the part ordered. And right now the tool is getting prepared to be ready so that maybe relatively late next week or so the part may arrive, and then we can add field service coming in and solve the problems, right? There's another issues that may have to be addressed, and that is already scheduled. So there's continuing work that goes on. Something that's important here to note after we figure out the condensation things, I guess, as the tool becomes online, it goes online again. Even before the part arrives, there's some room for temporary adjustments to get the tool working for some people, not for everybody, right? For some people, because it has maybe higher temperature, higher resist burning risks. So for certain users, if you're doing something very subtle and difficult, you may not want to use it. If you're doing something a little bit more coarse, or maybe it doesn't matter as much, at least you have a chance to use the tool once it goes online before the chuck arrives, right? So there's every now and then between repairs, we have the opportunity to have it partially up and running, and that's where it sits now. Doesn't mean we think it's good for everybody, but at least, maybe if half the users can benefit, that's already an improvement. So keep an eye on that, and we'll post these things. Just a very, very brief heads up on the Avionics, and we'll have more emails on that. The reason that it has vacuum issues. Right now, that's pretty stable, but it looks like in the next couple of weeks there may have to be some work to be done, and that might take about 5 days. Right. This is just a quick heads up because I know the tool is super busy, and we'll have additional emails go out when these schedules actually are fixed. Right. So, with all this stuff going on, how do we help you in the meantime? Really, what we have is from today. There's a whole bunch of problems and issues that arise. Some are COVID related, some are not COVID related, maybe tied to the shutdown or the lab for 3 months. So rather than having you be able to just go straight ahead and solve your problems, we can try to find workarounds. And that very much depends on your situation and the need and the timelines, right? And I want to give you 3 examples of this, and it's really tailored to a particular project. It's not generalizable as much, but for example, we can find solutions at MIT or beyond. At MIT, for example, we helped a user identify an underutilized etcher and be able to move their work into that tool until, let's say, the Oxford 100 is up and running. We found, did some for an external users, ran some wafers because they were lacking access to MIT, and it was a relatively simple step of coding and developing. Right, so that's something that we can do as well. And then beyond, there's one instance where we helped a user find access at peer institutions in case, as a backup facility, in case tool downtime was longer than acceptable for them. Right, so keep these things in mind as you run into problems. There are always some potential workarounds that we can try to help and find and work with you on. Now, I want to also then, with all of this, introduce a new thing called, I don't know, AWA or whatever I want to call it. Ask us almost anything, kind of like a Q&A wrap up for the week. And the way this works is that, maybe 11:30 at night, we'll email out weekly to Fab users a digest of any questions we have received with, as much as we can, answers that are available at that time. And yes, the little asterisk means I can include nagging things at the same time, so it's very convenient. But if you look at answers and emails, really what this works out to be is the following. Friday, 11:30 p.m., the email goes out. The chance of you getting your question answered depends on when you pose the question and what the question is. Right? There's sort of 2 extreme solutions. The top curve here is trivial questions, like, is the lab open on Monday? Okay, I don't need to ask a committee for that. I can just say yes. There's also impossible questions that will never get an answer because either they may be not making sense or they're just impossible for us to answer. But 99% of the questions typically fall in between that range. And are something like this, right? If you send us a question early on, we can go around the staff, get answers, get information. If you send it at 11 o'clock at night on Friday, we'll probably postpone it to the next week, and it all depends on the complexity of the question, right? That means if you ask a hard question, it just means that, well, you ask it here, probably low probability, but then for the next week, you'll have a pretty high chance that we'll be able to find you an adequate answer. So good answers can take time, so we appreciate your patience on that, but at least we'll post the question and say, yeah, we're working on that, so it's ongoing, and others know that it's ongoing. And if you want, you can ask the same question over and over again if you want to add more clarity, because we didn't provide or didn't have any information at the time. So hopefully that helps everybody to see what other users are thinking, what their concerns are. And obviously questions are posed when we digest them, it's anonymously, and we may paraphrase to help improve that anonymity. Not every question may be appropriate for Q&A for a short email, because we don't want to have the thing turn into an essay contest. But at the same time, if it's complex, maybe we'll postpone it to the next user meeting, right? So that's kind of our backstop there for difficult questions. Important though, all questions should go to MIT.nano feedback, right? Because otherwise, if you say, well, last week I sent a question to Bob, and how come you guys didn't answer it? Well, because we don't necessarily know what you asked Bob or send anybody else, right? So please email anything to MIT.nano feedback so that we can properly and easily aggregate and multiple people can see that question. I want to shift gears a little bit and talk about the external user. So last June in the user meeting, we provided you with the following updates. That's the end of the slide. Not much. We have a little bit more information now. So there were some recent developments just this week on external users that I want to share. Not precise answers yet, but we're starting to see light at the end of the tunnel here. And so we're anticipating, in general, I guess, simplifications as MIT's RR2 phase begins. And so maybe in 2 weeks, a lot of this will become a lot clearer. But MIT leadership is aware of the problems. We're getting positive feedback from them, and they are really actively working on a solution. That makes us very confident that we'll be able to solve some of the problems that we've been having and struggling with over the last 8 weeks. For instance, like this week, they asked us for a list of external users, which we then provided, so at least based on MUM. So if you're a current external users, you were going to be part of that list. And and so we anticipate getting a more precise timeline very soon, right? So that hopefully in 2 or so weeks' time. 2 weeks is always, I guess, as we know, the generic answer for anything. But in 2 weeks' time, we may be able to accommodate people. Just to give you an overview of what is involved, and this is actually a much broader problem that we have had with access in the building. And access-related issues really to users, vendors, staff, construction as we were ramping it up. Has really been a much larger problem over the last 5 weeks, and in some cases didn't even have proper access for staff. And maybe one good way to illustrate the complexity of that is that there's about 1,000 emails that I've either sent or received in the last five weeks related to these kind of problems, right? So that gives you at least a sense of the scope of what is necessary here. In the meantime, for external users, if we can help with simple things like you have to die-saw a wafer, you have to code something that is critically important for you to make progress outside the fab, let us know if there's things we can do to help you keep going. By all means, contact us and we'll see how we can best accommodate you there. The last thing I want to dive into now is a set of slides on the tool move and new tools. And just to give you an overview, because I think last time we had some questions about the phase 2 tool move, and I'm not going to say phase 2 because there's too many phase 2s all over the place. Okay, so the building 39 to 12 tool move this fall, plus any potential new tool installs. And typically what we did in the spring here was a design phase. We're now planning and bidding, and hopefully in September then we do the construction that will last until May. Now, it doesn't mean that in May we start moving everything in one big chunk, right? But it means that whenever construction wraps something up for a particular tool, we can start moving that tool. So what it looks like is the following, right? We have smaller tools here that may be easier to move, bigger tools that may move later or earlier. And so whenever we're ready, we can move a tool. And that's really important because that staggering lowers our risks, right? If we were to move 30 tools all at the same time, suddenly the staff of those 30 tools would have to struggle with new user training, with ramp ups, with qualifications, with a lot of stuff at the same time. And so by staggering it, we can spread that workload out and make sure that we don't really get significant disruptions, or at least we can minimize those as much as possible. In addition, though, just to give you a heads up, MIT has the process cooling water project ongoing that'll start in August and run also about until May. So there's really 2 construction projects happening in the clean room at the same time. And some of the tools that drives to a certain degree also at what point the big tools get installed or whether they get a temporary chiller until we're able to cut them over to the cooling water project.
And I will take it from here. The installation updates on the new tools and the future tools. So the most recent addition is a semi-lab spectroscopic ellipsometer, is a wide range UV to neo-IR ellipsometer. It will enable a lot of good characterization capabilities to the fab, upgrading from an older instrument. We will be able to get information on the thickness of the film, obviously, roughness, composition, doping levels, doping concentrations, not levels, concentrations, and crystalline nature, and maybe even electrical conductivity. There is a lot of indirect information that can be acquired from this instrument. The instrument is currently set up, it's installed, it's going through the qualifications, and Paul Tierney, the person in charge, to contact to coordinate the training. The next instrument is SEM, Gemini SEM. It is going through installation in the basement of MIT.nano. It has a lot of good capabilities of high resolution imaging for different materials, different charging materials, conductive, insulating. It has over 7 detectors being installed, and we hope to offer training at the end of August. Paul Tierney and James Daly are in charge, and you can contact them to coordinate the training. The next instrument is a Race Velion. So Race Velion is accepted mid-June. It was installed up until recently, up until yesterday. We did an RTL field labeling for the tool, and currently it's going through the qualifications. We anticipate qualifications to go until mid-August. And this is a very exciting tool that will provide a unique capabilities to the campus. It's coming with the 3 different ion sources, gold, silicon, and germanium, which allows a gallium-free milling. It can be utilized for nanofabrication and for TEM sample preparation. The beam diameter is a minimal beam diameter is sub 8 nanometer while using the silicon ions, which is really exciting. It has a large interferometer stage, which allows a minimal stitching errors on over 4-inch size wafers. So it will be, it's relatively slow tool, but it will enable continuous patterning. Young Yu is a RACE employee who is on site and will be helping people with the samples and getting trained in the observable future. All-purpose SAMCO, we are waiting for SAMCO for quite a while. It is finally arriving in August. It is a complex tool. It's unlike the ellipsometer. It is difficult to install, so it will take time for construction to prepare the infrastructure and for the installation. So we hope to have this instrument available for you in December this year. And obviously we will communicate more details as soon as we have them. All the facilities update can be found on the facilities update page, which Jörg pointed out earlier as well. Some future outlook, future tools. We are placing an order for Cypher VRS AFM this week. And this is the instrument that will live in the basement of MIT.nano and will enable dynamic monitoring of the processes. And how, like you can see in here, it's a molecular diffusion of alkyne lamellae that you can see in situ while heating the sample. The instrument can accommodate smaller samples. However, it comes with the perfusion chamber, infusion cell. So we can do in situ gaseous experiments or liquid experiments. It has a temperature controlled stage that can go from 0 Celsius to 250 Celsius. So even a very high annealing can be monitored. The cell is compatible with harsh chemical reagents. And the instrument also comes with a fast force mapping mode to enable advanced mechanical measurements, and ORCA for conductive AFM measurements. Next instrument is Jupiter. Jupiter is an AFM upgrade for the fab, and we anticipate to receive it in late fall. This instrument can accommodate samples of 8-inch in size. It has a fully addressable high-speed stage. So again, we can scan, although AFM scans are relatively small, about 100 nanometer maximum, 100 microns maximum, we are able to stitch and basically image the whole wafer if need be. The scan speed of this instrument is also significantly higher than what we have currently. So it will be a good support for the SEM and enable additional capabilities. It also comes with the ORCA conductive AFM, which might be very useful for large area patterning of the samples. And as soon as we have more details, you will post it in the facilities update. We are resuming the training and the orientation sessions. These are ongoing for a while already, but next week we will have a lot of help to users, to new users and existing users in form of orientations. Back to lab sessions that Whitney and Chris are having for the fab, and characterization back to lab sessions that I'm holding will be next week. One is in July 29th, another is July 30. Tool-specific trainings are ramping up. More staff are coming on site, and they will be available to help you better. We are still training on the new and similar tools, and in the future, very recent, like very near future, we will start accepting new users. The 24 hours qualifications are ongoing, and new users orientation will resume in July 28th for emergency preparedness and August 5th for the orientation for the FAP and for the characterization.